Hello everyone. Today myself, Abdul Hakim, and my co-researchers Haley, Rose Ellen, Yutin, and Hua will be presenting our assessments of the environmental impact of the Rush Fire, which occurred in California in 2012. We will first introduce the topic of this presentation, followed by the environmental conditions leading up to the Rush Fire. We will then introduce environmental impacts of wildfires and then explore a selection of these by analyzing freely available data, using open source software and tools specifically for the environmental impacts of brush fire. We will conclude by summarizing our findings. The National Interagency Fire Center provides data for each fire occurring. The graph was created in Excel to show the acres burnt and the year of the fire. 2012 shows Rush Fire, which we are focusing right now on this presentation. So a bit of background into this fire will be discussed. The climate of California has long dry summers and experiences below the United States average rainfall. The fire began on the 12th of August 2012 and continued until the 30th of August. It occurred roughly 15 miles southeast of Ravendale in California, USA. The main cause of the fire was a lightning strike on the 12th of August at 6:42 p.m. To date, it is the second largest wildfire that had occurred in California. Google Earth was used to show the location of the fire in the world, as we can see that it is in the northeastern part of California.
There were various contributing factors which allow the lightning to cause rush fire. If we take a look at this precipitation map, it shows the amount of precipitation which has fallen as a percentage of the normal amount. The deepest red color conveys the lowest amount of precipitation compared to the normal amount. The map therefore shows that there was a significantly lower amount of precipitation than usual in California during the weeks leading up to the fire. As you can see, where the fire began, there was only 2% of the normal precipitation level. Sustained low or no rainfall led to drought. This country maps shows that there was several droughts at the end of July and the beginning of August, moving to extreme drought at the end of August. This map is showing the average field moisture over 100 hours leading up to the ignition of the fire. The value represents the level of moisture in the vegetation. The less moisture there is, the more fuel there is for a fire to spread. The areas of green conveys the wettest vegetation, whereas the red areas conveys the driest vegetation. This shows that there was a significant level of fuel to start the fire on the 12th August. The National Interagency Coordinate certain combine these factors into one map to show the fire potential for August. The areas of green show lower than normal potential and red higher than normal potential. For Leysen, California, there is a high potential for wildfire to occur.
We have looked at the causes of the fire. We will now look at the environmental impacts. An environmental impact is any effect on the environment due to activity, such as a fire. Environmental impacts can either be positive or negative, such as reduction in air quality or an increase in fertility of soils. Previously, in California, there have been various environmental impacts which include increases in soil fertility, reduction in air quality due to dust particles disappearing into atmosphere, decreases in vegetation due to it being burnt away, decreases in wildlife, livestock, and migratory birds due to destruction of their habitats, and reductions in water quality due to deserts. Previous wildfires in California have affected vegetation, air quality, and wildlife, so the impacts upon these will be looked at in regards to the Rush Fire. We will now look at the data sources necessary and what is available to determine the environmental impacts of the above. To see how any of these environmental impacts are affected, especially the area built, must first be defined. Models detects near real-time thermal anomalies, and NASA provides this freely available data of the areas that have been burnt. Maps have also been created in reports, which show the extent of the fire. To look specifically at the effects of the fire on vegetation, an index can be used which identifies where vegetation is and the health of it. Normally, the Differentiated Vegetation Index, that means NDVI, is a useful proxy to determine the location of vegetation. Models freely provide global NDVI values at 250 meters every season to 10 days. 250 meters is a large expanse to determine the location of vegetation, and so 30 meters Landsat data, which is available every 16 days, will also be used and compared. To calculate NDVI for the Landsat data, a simple inclusion was used as shown. To look at vegetation change NDVI, images before and after the fire were needed. These images were collected at the beginning and end of August. An NDVI difference image was calculated for the Landsat data to convey where vegetation has altered. An NDVI difference image was calculated for the Landsat data to convey where vegetation has altered before and after the fire. An NDVI difference image was also created to compare the level of vegetation at the same time of year. And in this task, we used QGIS as a tool. QGIS is an open source piece of software which has a similar functionality to ArcGIS. It provides a platform to open remotely sensed imagery and vector data to perform simple processes on it. It also allows the imagery to be outputted as a map.
Air Quality Index considers other parameters. We only chose to look at fine particulate matter obtained from air now. These are environmental monitoring stations around the US to provide daily air quality updates. Using a GIF generator, these show differences in fine particulate matter over time. Giovanni's air quality portal contains AirNow air quality data, but in a different format. So a time average graph could be generated. In addition to the fine particulate matter, the AIR's online visualization analysis generated a carbon monoxide graph. Report maps have been generated by various organizations to display these and take them into consideration. We have imported them as image overlays into Google Earth by stretching them out to the state of California. The rationale to using report maps which are not georeferenced is because there is no immediately available spatial datasets. For the greater sage grouse, it was available, but for other animal species, an order had to be put into Nature Reserve. However, this service is free. We could use data from SAGE publications, but it did not come in time. Now we have looked at the methods, we can now look at the results. Firstly, we will concentrate on how vegetation has been environmentally impacted upon. The US Department of Interior Bureau of Land Management states that sagebrush steppe was a type of vegetation burnt in the brush fire. California's climate makes it susceptible to frequent wildfires, with large areas being burnt. In 2000, there were 4,000 fires, which burned a total of 40,000 acres. NDVI will be used to determine which areas are burnt following Leon, Van Leeuwen and Cassidy methodology. The area burnt equates to 280,000 acres in California, and a further 40,000 acres in Nevada was burnt due to the Rush Fire. The animation shows the fire movement. The fire radiates from a central point, and it shows the development of the fire over time. The image shows NDVI values before the fire in August. As you can see, these white areas disappear after the fire, showing a loss in vegetation. Due to the low spatial resolution of MODIS, Landsat imagery was used to look at NDVI. This image shows NDVI before the fire, and this image shows NDVI after the fire. As you can see, there is an increase in vegetation. As shown in this vegetation difference image, this slightly is due to the health of vegetation being minimal before the fire due to drought and low precipitation. The increase is due to increased facility. However, when comparing NDVI values between August 2011 and August 2012, it is clear to see in this difference image that vegetation has decreased. The animation of the fine particulate matter is for the whole US, but if you look at California, the fine particulate matter concentrations are low, and the fire starts on the 12th, but as we've seen, the fire becomes more active on the 13th of August, which is seen in both the particulate matter and the carbon monoxide graphs. Rush fire was not the only fire to occur in August, as shown in this image. We considered this fact when looking at the air quality index from AirNow. We can refine the search parameters in Giovanni to only around the area of rush fire. The phenomenon can be determined to have an environmental impact, as shown in the graphs on the previous slide.
In addition to the air quality and physical area burn, there was an impact on the habitats for several animals. In a clockwise order, trout, deer, pygmy rabbit, and the greater sage grouse was affected by the fire. There will now be a demonstration of how each species is impacted upon by the fire. The report maps have been stretched onto Google Earth. This map shows that trout are likely to be affected by the fire due to reduced water quality from burnt sediment entering the river. Deer will have also been affected by the fire as shown. Finally, pygmy bunnies, which are an endangered species, have habitats where the fire was burnt. This slide shows part of the greater sage grouse habitat for the year 2009. The Rush Fire burn extent is shown. There is habitat loss as a consequence of the fire. There is going to be uncertainty created at points of data collection and data processing. For our project, we had identified these three areas for uncertainty in the area quality data. The air quality is not just affected by rush fire, but actions were taken to only include data for the specific fire by selecting a small bounding box in Giovanni. There is uncertainty in the data capture as satellite imagery needs to be atmospherically corrected, cloud masks need to be applied, and georectification is necessary. There is uncertainty in with the data processing created by stretching wildlife maps to the rough geographic place, which is not geographically accurate, but Google does display the information well. Ideally, with a longer time period, we would have looked at the long-term effects. If a fire occurs in the same place within 5 to 10 years, it prevents native vegetation growth and allows invasive species and weeds to multiply. So, in conclusion, we have introduced rush fire to you, and we can say that the fire was expected due to drought, low rainfall and high fuel capacity. The environmental impacts of this fire were analysed using Landsat and MODIS by calculating NDVI, and there was an overall decrease in vegetation. Air quality used a larger spatial extent than required, but the particulate matter concentrations provided by AirNow are provided daily. Giovanni can be used to access AirNow data in different formats and carbon monoxide concentrations. Finally, the impact on the wildlife includes burnt vegetation of the ground sage grouse, pygmy rabbit, and deer. These are our references. Thank you for listening. Do you have any questions?